All right. Number 5, part B, says the probability is approximately 0.42. When they give you a probability, that's an area. All of our probability models have the area as 1. So they're giving us the area. It says up at the top in the question stem that it is approximately normally distributed with a mean of 250 pounds and a standard deviation of 50 pounds. So I would draw my normal curve. I would draw a normal curve for part A also. Right down the center is where the 250 pounds goes. N of 250 and 50, labeled as the mean and the standard deviation. For an area of 0.42, well, if I go all the way up to the line, that's half the area. That would be 0.5. So I want something that's a little bit less than that, but I don't know where that's falling on the x-axis. I do know that this area is 0.42. Got it. I will leave it here. Hopefully somebody comes looking for it. I'll take it down to the office if nobody comes. Okay. So if we have the area and we are looking for an x value, how do we do that? Normally we have the value on the x-axis. That's when we do normal CDF. When I already have the probability, how do we approach that? Yep. If we already have the area, how do we approach those problems? Guys, phones away, please. How do we do a problem where we have the area? Inverse norm. So we would do inverse norm. On the calculator, it prompts you for the area first. So 0.42 for my area. Then we need the mean of 250, so I'm going to label that. Then we need the standard deviation, which is 50. And then we have to decide on our tail direction. Which direction do we have it shaded? Left. You do not have to write that part down. You do not have to write left, but you do need to know when you're putting it into the calculator whether you want the left tail or the right tail. And what do you get when you do inverse norm? You said 239 point what? 239.91, and we would put pounds with that. What else would you guys like to look at from the review? Yes. Number 12? Absolutely. Number 12. Too far. There we go. So to do number 12, we have to do number 11 because it said using the same scenario above. So let's look at number 11, figure out what that answer is so that we can go down and do number 12. 11, Jen's commute to work requires that she take the blue subway line, then transfer to the red line. The length of the trip on the blue line has a mean of 18 minutes with a standard deviation of 2 minutes. So I'm going to underline that. The red line trip takes 12 minutes with a standard deviation of 1 minute. The waiting time between when she gets off the blue line and her red line train has a mean of 10 minutes and a standard deviation of 5 minutes. Assume, perhaps unrealistically, that these times are independent random variables. What are the mean and standard deviation of her entire commute? So the mean of her commute, she's adding all these times together, right? So we would do the mean of the blue line plus the mean of the red line plus the mean of the wait time in between. Because she's got this waiting time in between the two subways. So mean for the blue line is 2 minutes. Or sorry, 18 minutes, my bad. I read standard deviation. Mean for the blue line is 18 minutes. Mean for the red line is 12 minutes. And mean for the waiting time is 10 minutes. So that comes out to be what? 40. So we have a mean for the entire commute of 40 minutes. So I know it's not choice D or E because that has the wrong mean. For standard deviation, can I just add the standard deviations like I did with this? No. What can I add though? I can't add the standard deviations, but what can I add? The variance. We can add the variance. How do you find the variance if all you have is the standard deviation? Square it, yes. So the standard deviation for the whole commute is equal to, after you square them and you add them together, what do you have to do? Square root that. So we have to undo the squaring. So I need the standard deviation for the blue line squared, plus the standard deviation for the red line squared, plus the standard deviation for the waiting time squared. So for the blue line, yeah, I get 2 and then squared. Red line is a 1 minute standard deviation, so 1 squared. And the waiting time has a standard deviation of 5 minutes, so 5 squared. So that'd be 25, 29, square root of 30, I think, if I'm doing this right in my head. I get 5.477. So correct choice here would be what? B. Correct choice is B. All right, so now that we know the mean and the standard deviation, let's go down and look at number 12. Using the same scenario above, if you randomly select 3 people who take the red line, what are the mean and standard deviation of the sum of their times? If it is known that the wait times are approximately normally distributed, what is the probability that the sum of travel times of these 3 people is less than 40 minutes? All right, so if we're doing 3 people all on the red line, the mean for 3 people taking the red line, I would do the mean of the red line plus the mean of the red line plus the mean of the red line. Mean for the red line was 18. So we have 18 plus 18 plus 18. Gives me a mean. Oh wait, I looked at the blue line, didn't I? Yeah, sorry. I looked at the number for the blue line. What is the mean for the red line? My apologies. 12. 12 plus 12 plus 12, not 18 plus 18 plus 18. I apologize. We get 36 minutes for the mean. We need the standard deviation. Standard deviation for 3 people taking the red line is going to be the square root of the standard deviation for the red line squared plus the standard deviation for the red line squared plus the standard deviation for the red line squared. What is the standard deviation for the red line? 1. So 1 squared plus 1 squared plus 1 squared. We end up with the square root of 3, which is about 1.732. And that would also be minutes. It said that this was normally distributed. So if I want the probability that X is less than 40, we will do normal CDF. If I'm doing normal CDF, what else do I need on this problem? Anytime you see normal, what do I need? I need a picture. Anytime we're doing stuff with normal, we need a picture. I'm going to draw my picture down here. N with a mean of 36. I'm going to have to scoot this picture over. That's not enough room. Put it right here. 36 and 1.732. Make sure those are labeled as the mean and the standard deviation. Right down the center, we would have 36. We want the probability that it is less than or equal to 40. Thank you. So 40 is going to be over here somewhere. Less than or equal to means I would shade this way. Less than or equal to, when we're talking normal CDF, anything continuous, there's no difference between a less than and a less than or equal to. With binomial and geometric, there is a difference, but with normal, there's not. So I could do less than or equal to with a normal CDF. What's a reasonable lower boundary here? 0 would work. You can always get away with something stupid small, like negative 9999. But 0 would be fine. 0 is small enough here. Upper boundary, 40. Mean, 36. And standard deviation, 1.732 is my standard deviation. Please make sure that you are labeling those numbers. So then the probability that X is less than 40 comes out to be about what? Yes, 0.9895 if I take it out to 4 places. All right. I guess technically we didn't have to do number 11 first, but I thought we needed to because of what it said. So we got a freebie. What else would you guys like to see? Yes, David. 17. 17. The length of human pregnancies from conception to birth varies according to a distribution that is approximately normal, which means we're going to need what? A picture. You are going to need a picture. Says it has a mean of 266 days and a standard deviation of 16 days. Choose 2 pregnancies independently and at random. What is the expected difference in the lengths of the 2 pregnancies? So the expected difference, anytime you see expected, we're asking about the mean. So the expected difference, that's supposed to be a D right there for difference, would be the mean of pregnancy 1 minus the mean of pregnancy 2. What would the average for pregnancy 1 be? It is 266. Minus, what's the average for pregnancy 2?
250.
Nope.
282.
Nope. What's the average for any pregnancy? What'd you say, Alyssa? The same as the first one. The average for all the pregnancies is 266. So if I look at one person and say, what's your average? That's 266. Somebody else, it's also going to be 266 because that's the average for the group. So 266 minus 266, I would expect a difference of 0 days between these 2 pregnancies. I would expect a difference of 0 days. What is the standard deviation of the difference in the lengths of the two pregnancies? So I want the standard deviation for the difference. Do I subtract the standard deviations?
You add under a square root now.
I add under square root, but first I have to square them.
Okay.
Take the standard deviations, square them, add them, square root them. We never, ever, 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 ever subtract with standard deviations. So I want the standard deviation for pregnancy 1 squared plus the standard deviation for pregnancy 2 squared underneath my radical. What is the standard deviation for pregnancy 1? How much? Standard deviation for pregnancy 1. 16. So 16 squared plus, what's the standard deviation for pregnancy 2? 16. So we do 16 squared. All underneath our radical. That gives me a square root of 512, which comes out to be about how much? Yes, 22 point. If I take it out to 3 places, I got 627. That would be days. They didn't ask for an interpretation of this, but I want to make sure that we understand what we just found. So if I have 2 people that are pregnant, that let's say for argument's sake, we know that they got pregnant on the exact same day. My expected difference in the days that they actually give birth is 0. I expect that if they got pregnant on the same day, they're going to have the baby on the same day. Typically, it's off by about 22, 23 days. So on average, the day that they give birth will typically vary by 22.6 days from the mean of 0 days. Find the probability that the difference in the lengths of the 2 pregnancies is greater than 25 days. Whenever they give me a probability or it says find the probability and it is normal, draw a picture. Yes, sir. If you don't draw a picture, yes, you will lose points on questions like this. Yes, you will. Anytime it says normal, you want to be drawing a picture. So right down the center, what do we put? 0. Big N next to it, 0, and yes, 22.627. Make sure you label those numbers as the mean and the standard deviation. We want to know what is the probability that the difference is greater than 25 days. So we are going to do a normal CDF, yes. But I want to stop and think about this for just a second. I'm going to mark my picture up. 25 would be over here somewhere, right? Isn't there somewhere else I could put a marking where it's 25 days or more? Negative 25. This would have the first person having their baby first, and then the second person having their baby. So I'd get a negative difference. The other one would be second person has their baby first. So we're going to do the probability that x is greater than 25 or x is less than negative 25. This is what we are finding the probability of. So I'm going to do normal CDF. I have tails that are going in opposite directions. But this is symmetric, right? What would that mean?
1 minus.
The probabilities in those 2 tails are the same. So if I find the probability in one tail, I can just double it to find the probability in both tails. So let's do the probability for just one of these. Let's do the upper tail. So 25, 9999. 0, and 22.627. So here's my lower boundary, upper boundary, mean, and standard deviation. But then I'm going to take this answer and times it by 2 because we have 2 tails. So I end up with 2 times, this comes out to be about 0.1346. So we get about 2692. Yes.
Why did 7 sneeze?
Why did 7 sneeze? Because it's a 6-7. What else would you guys like to look at?
Can we do 16?
16?
Yes.
Absolutely, we can do 16.
Oh my God.
Suppose that 45% of the people in a large community have type O blood. You randomly select people from the community until you find someone with type O blood. Ooh, until, yes. We're going until success.
Oh.
So this would mean we're talking geometric. Let X equal the number of people selected until you find a person with type O blood. Determine whether each random variable described below satisfies the conditions for a binomial setting, a geometric setting, or neither. Sorry, this should say described above, not below, because they described it above. And we only had 1 random variable. So what do I need to check to see what type of random variable it is? What do I need to check to see what type of random variable it is? Bins, yes. All right, so what does the B mean? Binary. Is this binary? Yes. What is success?
Somebody with O blood?
Yes. Success would be type O blood. So what would failure be then?
Not anything else.
Yes. Failure is not type O blood. Is this independent?
Yeah. No.
It's
Yes. No, but it follows the 10% rule.
I love it. Technically, it's not independent, but as long as I write down my check and I show that it meets the 10% condition, we can get independence. What'd you say? Well, 45% is not what we're looking at. 45% is not what we're looking at. Hold on, let me see where I got this number from. I'm looking at my answer key and I don't see where I got the number from. You randomly select people from the community until...
the large community.
So as long as we sample less than 10%, we are okay here.
How do we know that though? Yeah, large community is kind of like.
Right, there's no sampling described.
There is no sampling described, you're right. There is no sampling described. So we could just write down 10% condition must be met. What would I put for N? Many people. We're going to go until what? Yes. Until success. What do I put for S? What'd you say? Yes. Probability of success would be 0.45. So what kind of random variable is this? Geometric. Please make sure that if you are asked what type of random variable something is, answer that for sure, but you need to provide support for that. Even if it doesn't say support your conclusion, if I ask you what kind of random variable it is, you have to show me your bins check to be able to support that it is binomial or that it is geometric. Yes.
On the question we have, it doesn't say until you find someone with type of blood.
Yes, it does. It says.
It doesn't say.
The second sentence.
Right here. Let X equal the number of people in the sample with type O blood.
It doesn't say until you find someone with type of blood.
Interesting.
So that,
Oh, and it says you take a random sample of 20 people.
That's it.
You're on 15.
Oh.
I'm on 16.
Oh my god, I'm sorry. Oh my god.
That's okay. But that would explain it. I was like, wait a second.
Because I was
What's
like,
going
I
on?
don't see it over here. That makes sense.
Okay. Find the expected value of X and the standard deviation of X. So I want the expected value. Remember, expected value is mean. How do you find the mean for a geometric random variable? This is on the formula sheet. You get the formula. 1 divided by P. So this is going to be 1 divided by what? 0.45. What is 1 divided by 0.45? The number of points has nothing to do with how many right answers there are. It can be 1 answer, it can be 5 answers, it can be all 6, it could be anything in between. The number of points has nothing to do with how many right answers there are. Yep. What do we get when we do 1 divided by 0.45? 2.222 people. And then we also want the standard deviation for X. How do you do standard deviation for a geometric random variable? Square root of what? Nope, not for geometric. 1 minus P over P. So we would have the square root of 0.55 over 0.45, which comes out to be about 1.648. Find the probability X equals 12 and the probability that X is greater than 12. So let's first do the probability that X equals 12. What does that mean? Yes, that on the 12th person we find someone with type O blood. So that means we had how many failures? 11 failures. What's the probability of failure? Bless you. 0.55. So this would be 0.55 to the 11th times 0.45 to the 1. Do you have to put the 1 there? No, it doesn't matter if you have the 1 there or not. And we get 0.000627. Sorry. The probability that X is greater than 12, can we do greater than using the calculator? No. We can only do what? Less than or equal to. So if I have a greater than or I have a greater than or equal to, what do I have to do to calculate that probability? If I want my inequality to go the other direction, what do I need to do? Yes, 1 minus the probability that x is less than or equal to what? 11, yes. So I would do 1 minus, what kind of random variable did we say this was again? Geometric, so geomet CDF. What parameters do I need to give geomet CDF? I don't need a lower boundary on this one.
Oh, it's less than or equal to.
It is less than or equal to. Normal CDF, I have to feed it lower bound and upper bound, mean and standard deviation. Got it? Got it. Thank you. What are the two things that we need to feed geomet CDF? Probability and x, which is our upper boundary. What is the probability? 0.45. We're going to label that as P. And what is my boundary? 11. We're going to label that as X. So I do 1 minus geomet CDF with P 4.45. And X is 11. So this would be 1 minus, this comes out to be about 0.999. So I get 0.001. Squeezed way down at the bottom, what is the probability that 12 people are selected and no one has type O blood? How would I calculate this?
You do 0.55 to the power of 12 times 0.45 to the power of 0.
Yes. 0.55 to the power of 12 times 0.45 to the power of 0. What is anything to the power of 0? 1. So do you actually have to have this part right here? No. And we get 0.000766. What else would you guys like to look at? Yes. 15? Yes.
So why are we doing so why do you use 1 minus to the power?
I kind of feel like
That's a greater than. The equal to?
Yeah.
I didn't do a 1 minus up here because it's equal to. I did 1 minus down here.
Exploded, but you just 0.55 is what you got from the 1 minus.
Oh, 1 minus P. Yes, that's the probability of failure. If x is equal to 12 and we're talking geometric, this notation right here for a geometric random variable means we had success at the 12th person, which would mean we had 11 failures and then a success.
Oh yeah, okay, I see it. Just sorry.
Nope. 0.55 to the power of 11 and 0.45 to the power of 1. Right. You wanted to see 15. Ebony, you had a question? Yes. Give me a second, please. All right, 15. Suppose that 45% of the people in a large community have type O blood. You take a random sample of 20 people from the community. Let X equal the number of people in the sample with type O blood. Determine whether the random variable described above satisfies the conditions for a binomial setting, a geometric setting, or neither. What do I need to do? Bins. One more time, bins. Well, so far your guessing is paying off. So just like before, success would be type O blood, failure would be any other type of blood. Success would be Good question.
What's the denominator? It is geometry, isn't it?
This one?
Oh, it's not that one. Never
Yep.
mind. Never mind.
Can I actually check the 10% condition here?
No.
Not really, no.
Yeah.
Good.
Yes. How many people are we sampling?
20.
20 is less than or equal to 10% of people in a very large community, right?
You could. 100 could be a very large.
Yep.
It could.
We could say all people in a very large community.
So very large, we can assume it's like 500.
Like, we would be okay to make this assumption here.
Yeah.
If it says a very large community, 20 should be less than 10%, but we still have to show that we have checked that condition. N, what would N be here? 20. And P? 0.45. So what kind of random variable is it? Binomial.
Oh, that was
Yeah, 15 is binomial. 16 is geometric, because 16 says we're going to go until we find somebody with type O blood. This one just says, I picked out my 20 people. We're going to see what happens. Find and interpret the expected value of x and the standard deviation of x. When you see expected value, what am I asking about? The mean. So how do you find the mean for a binomial random variable? Yes, NP. So this would be 0.45 times 20, or 20 times 0.45, which comes out to be 9. How do we calculate the standard deviation of x? N times P times 1 minus P. Remember, you get all these formulas on the formula sheet. You do not have to memorize the formulas. So we have square root of 20 times 0.45 times 0.55. And we get about 2.225. Now they also asked for what?
Oh, sorry.
Interpretation. So finding n times p is not enough. We have to interpret what does n times p mean. Finding 2.225 is not enough. We have to interpret what does 2.225 mean. So let's look at the average here, 9 people. Give me a little bit more.
With each sample?
If you sample 20 people with a 0.45% chance of them having type of blood, then you get an average of 9 people in the 20 having type
Yes.
of blood.
I would word it just a little bit differently, but yes, I like that. So if I were to sample many groups of 20, like we described here, on average, I would expect about 9 of them to have type O blood in the long run, if I do this over and over and over. So let me see if I can fit that in. After many samples, let me write this down and then I'll answer it, of 20 people, about 9 of them will have type O blood. After many samples of 20 people, about 9 of them will have type O blood. David, was your question about this or about the next piece? Okay.
What if we just put
How do you think a reader is going to read that? Do you think that that is effective communication? Because whenever we are putting things into words, we want to make sure that we are communicating clearly. Is that something that you would put on a report at work? Then I probably wouldn't do it. Yes?
On the first one, didn't you say in the binomial we have to put the N and the P?
Yes. And the only reason that I did not put that right here where I wrote binomial is because right over here I did write down N and P. As long as it's in that question part, you should be okay. Yes. You need to clearly have identified N and P. Now, they really like to see it right with this binomial with N equals 20, P equals 0.45, so that way it's all in one convenient spot for the reader. But as long as it is in that question section and you have clearly identified and labeled them, you would be okay. What does the standard deviation of 2.225 people mean? Thank you. On average, the amount of people.
No, I don't want to.
On average, the amount of people that deviate from the mean
What'd you say? B is just a point. B is a dot. This is an angle. They have the same center letter, so they have the same vertex, but they're facing different directions. All right. So what I would say for my interpretation here, the number of people with what quality? What people are we interested in here?
With type O.
Yes, the number of people with type O blood in a group of 20, because if I have a bigger group, I would expect there to be more variation. So the number of people with type O blood in a group of 20 typically varies by 2.225 people from what? Yes. From the mean or the average of 9 people. Find the probability x equals 12 and the probability x is greater than 12. So the probability x equals 12. We're talking about a binomial random variable. So what comes right after my probability notation and my equal sign?
Probability x is.
Look at your formula sheet. That's okay. Look at your formula sheet. This is in the table in the middle of the page. Find where it talks about the binomial random variables. Don't look at the column for mean or the column for standard deviation. Look right where it talks about a binomial random variable. Because, yes, n over x. So what is my n? What is my x? 20.
X is 12.
Yes. And then we would have what? 0.45 to the power of 12 times 8. Y to the power of 8. Yep. If we have 12 successes, that means 8 failures because my group size is 20. How do you actually put that in the calculator, though? 20C12. And you can type this all into the calculator. You don't have to find what 20C12 is. You can do 20C12 and then keep typing next to that. You don't have to hit enter. We come out with about 0.0727. All right, so now we need the probability that x is greater than 12. Can I do greater than with binomial? So what do I have to do? Yes, 1 minus the probability that x is less than or equal to 11. So 1 minus, what function do I need to use? Binom CDF. What 3 parameters do I have to feed in for binom CDF? Yep, n goes first, and it'll prompt you on the calculator. So we would have 20. We're going to label that as n. Please, please, please make sure you are labeling these pieces. P is 0.45, and I am going to label that as P. And then x would be 11 here. I'm going to put an x over the top. And then I can type that whole thing into my calculator just like that. I get 0.058. 0.058. All right, we are like 2.5 minutes till the bell. Answer key is and has been posted in Canvas. Please, 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 the best practice I can give you for the test is to work through this test review. And I would highly recommend, if you have not finished the multiple choice practice, please go in. There are questions on the multiple choice practice that are not on the paper review, and they are still fair game for the test. Anything that was in the multiple choice practice is fair game for the test. I just didn't want to give you guys like a 10-page review. So that's why we do some of the multiple choice practice on Canvas first. All right?
I get that. The thing is,